So lesson 8, I think this is unit 7, lesson 8. Ignore what it says up there. That should say unit 7, lesson 8 is really an assignment. We sort of put everything together. So I think what I will do is I will read The Cat in the Hat Comes to Math Class, the poem that I have written, and I will highlight where the math is, the problem that you have to solve, and then the assignment at the bottom. So let's see how well I can read this. I'm going to pause just for a second. All right, we're ready to go. The clock must have stopped as we sat in math class that day. We'd never get out. I was certain there's no way. Sally and I, we sat there, it's true, perimeter and area. We weren't sure what to do. It was a problem the teacher wanted us to complete. We were to be very careful and especially neat. Look at me, said the teacher. Look at me now. Rectangles with the same perimeter, you have to know how. But as hard as I tried, I could not stay awake until a big bump caused me to shake. I opened my eyes and our teacher was gone, and the cat in the hat was out on the lawn. Then he strolled into our room with a box over his head. Get ready to have fun, is what the cat said. In this box you will find something new, 2 little things called thing 1 and thing 2. He jumped on the box. He jumped on the box and opened the lock, and both of us were too excited to talk. But slowly out of the box came thing 2 and thing 1. They looked rather sad. They didn't want to have fun. They explained to us that they were in a real bind. They hadn't done their homework and they were really behind. Their problem was in math, as you could probably guess. It was area and perimeter. What a coincidence? Yes. They had 50 meters of rope with which to enclose a rectangular ground for play. Whoever enclosed the biggest area was champion for the day. The area enclosed could be increased with an extra piece of rope, but we must find its length, and we don't think we can cope. The rope can be used to create a semicircle on side 1, plus an equilateral triangle on another for fun. How much rope will we have to use in all? The total area enclosed? Is there a friend we can call? To make a patio, they were also given 100 square tiles. The one with the smallest perimeter will get the most smiles. Find the dimensions of this patio to stay in the game. Our lives in math class will never be the same. Sally and I knew they needed our help, but what could we do? We didn't listen to the area and perimeter lesson too. But then Sally jumped up and started to shout, if we all work together, we can figure it out. And that's what we did with thing 1 and thing 2. We found the answer. Can you find it too? So the first 1, 2, 3 stanzas are just kind of a lead-in with rhyme. The math is going to be found starting here. So this is the 50 meters of rope. Turn the highlighter on. And we need to enclose the biggest area. And we're doing rectangles, so that's optimizations with rectangles. And then we're going to get an extra piece of rope right there. Let's highlight that. That's important. And we can create a semicircle on one side with that. And then we can close in an equilateral triangle on another one. And how much rope will we have to use in all? I'll draw a little diagram later. I'll pause and draw a picture just to explain this better. And then we need the total area. So those are the keys there. So the first part of these are going to refer to that one. The dimensions of the original rectangle for the largest area. So take that 50 meters of rope. What rectangle will enclose the largest area? Then the amount of additional rope that you need, because you're going to put a semicircle and equilateral triangle on 2 of the sides. Then the total area enclosed by those 3 shapes, and all of that's from that stanza. Now I'm going to change the highlighter to pink, and now you're getting, whoops, not on that one. All right, let's click off. Now I'm going to change the highlighter to pink, and now we've got 100 square tiles, and you want the smallest perimeter, and you just need to give the dimensions. So what are the dimensions of this rectangle? And so what I'm going to do now is I'm going to pause, and I am going to, I think I'm going to draw some shapes, what this will look like, and just to give you better direction on how to create this, and exactly what would need to be submitted. All right, the first thing I'm going to talk about is just this first part. where you have to find the dimensions of the original rectangle that's going to enclose the largest area, and bear in mind you have 50 meters of rope. So how are you going to answer this question? That's question 1. I am going to note for you that the length plus width should be half the perimeter, which is 25. And you're going to set up a big chart, length, width, area. If the length is 0, the width would have to be 25, and that would give us an area of 25 times 0, which is 0. If the length moves to 1, then there's 24 left for the width, and 1 times 24 is 24. So you can take a look at the lesson 6 to help you fill in this chart. Based on lesson 7, we actually took data from the chart and we graphed it. So you'll graph area versus width, and you're going to highlight, lesson 7 pointed out, because you should get a curve that looks like that. Highlight the spot where you get that vertex, what's the highest area there. Highlight the spot in your chart. Include all discrete values, so 0, 1, 2, 3, all the way out to 25. You should end at 25 for the length. And what you'll find is that you don't actually have a spot yet where the length and width are equal to each other. You'll see the same patterning as they get closer together. The area will increase, but you won't have them equal to each other. So I'm asking you to find what that answer is and put that at the very bottom of the chart. So this is continued until I got to 25. You're going to put all the values in. The width is 0, the area is 25. And then after that, you're going to then include a row where you give me the correct decimal answer where it's absolutely minimized. Okay, that's part 1, and now I'm going to set up for part 2. Okay, continuing to explain how you would approach the second part, which is the additional amount of rope required to create both a semicircle and the equilateral triangle. So if you've done the first part right, which was this one over here, you will have found when you've got the length and width to be equal to each other, you will have created a square. So you've got this square. You should know what this number is. Then what you're going to do, the extra rope, it said, let me pause because I want to paste that stanza here. Okay, so starting up again, it said, the rope can be used to create a semicircle on side 1, so any side I can put a semicircle. It could be on any of the 4, it doesn't really matter. And then an equilateral triangle on a different one. So because this is an equilateral triangle, all of these sides will be equal. Then what it's asking you to find is the length of the extra rope. So the length of the extra rope will be these pieces here in red. 2 of these, that shouldn't be hard to find because it should be the same as this. And you know how to find the circumference of a circle. It's 2 pi r. The only thing you have to remember is that this is not all the way around a circle, it's only halfway. Then you'd add those values together, and that would be the answer to question number 2. I'm going to pause now so I can set up number 3. All right, so explaining what's happening here. Part 3 says you need to find the total area enclosed by all 3 shapes. This white area shouldn't be hard to do because you were required to find that in 1. That was in your chart and your graph, and you summarized that in 1, so you know this area. Here we have a semicircle. The formula for the area of a circle is pi r squared. You should be able to tweak that. You can find the radius because you will know how long this line segment is. I'm just going to take half of that to find the radius. And now we need to find the area of this triangle. The formula for the area of a triangle is base times height divided by 2. So I'm looking at, I'm going to highlight that, going around there in yellow. And I've just kind of brought that over here. And because this is an equilateral triangle, this is a base, but so are both of these. So this is a base here, and that's this side right here. And now this little bit is going to be half of the base. So I put half of the base there. So in this right triangle now, I'm going to change back to purple. That's the hypotenuse. And you're going to have to use the Pythagorean theorem here. And remember, the Pythagorean theorem is h squared equals a squared plus b squared. So you're then going to have to find the base, you know, because you found that in 1. You can find what half the base is, and you're going to have to use the Pythagorean theorem. Now remember, this is h for height. It's not h for hypotenuse. This one is the hypotenuse. Then you can find the height, and then you can plug in there, and then you'll have the total area. I'm going to pause one more time because I need to set up for number 4. All right, so let's discuss 4. And reminding you again, in 4, they're giving you 100 square tiles, and you're after the smallest perimeter. So that's what was happening in 4. And so you can again look back at lesson 6 where we created the initial chart. Lesson 7 was where we created the graphs. And so now we know that length times width is supposed to be 100. And that means that the width is going to need to be 100 divided by the length. Just reminding you can't put 0 in here now, because if you put in a 0, you'd have 100 divided by 0, and that's undefined. I'm just going to put DNE because that won't exist, because 100 divided by 0 doesn't exist. Now, if the length is 1, then 100 divided by 1 is 100. And note that 1 times 100 gives me what I'm after. And now I need the perimeter. So I make the perimeter calculation as 2 times in brackets L plus W. That gives me 202. And then you could continue with this chart. And what you're going to populate it with are the factors of 100. So how are you going to justify and get full marks for number 4? You've included a chart that has all the factors of 100, and you drew a graph. And make sure for number 1, for justification to get full marks, you've included a chart with all of the discrete values, add the decimal answer on the end, and you've included a graph. And if you don't remember how to graph, again, you can look at lesson 7. And here we've talked about, I need to see your calculations. You might want to draw that picture and include all of your calculations neatly on paper. Include your calculations for the area. I explained how to get that going. And we've discussed what has to happen here. And then there's one last thing you need to do. So I'm going to pause. All right, and then the last thing you'd have to do is you have to write a short report in 8 lines of rhyme that indicate what the answers to the above would be, i.e., you've indicated what are the dimensions of the rectangle with the largest area? How much extra rope did you need? What was the total area enclosed by the 3 shapes? And what are the dimensions of the rectangle that has the smallest perimeter? So I'm going to say at least 8 lines of rhyme. I believe you could do it. This little poem that I wrote here included 42 lines of rhyme. I was able to do it, and I'm not the English teacher, I'm the math teacher. So we will grade that as an assignment. So that's what lesson 8 is all about. You solving all of those questions from 1 through 4, and then 4 lines of rhyme. Again, thanks for watching, and good luck with the assignment. You can contact me if you have further questions.